Hi there again. So this week you got familiar with the concept abstraction, and that is exactly what this is. We used a piece of generalized code, and we did this so we could reuse it in different types of situations. That is what abstraction means. Also, in the real world, we are dealing with abstractions. Think of the recipe of baking pancakes and the recipe of baking some eggs. Those are two totally different dishes, but if you would generalize it a little bit, you could have the same sort of recipe for this. Because for both of these dishes, you put a pan on the fire, you put something in the pan, and then you wait for a bit. You turn what's inside around, so either the egg or the pancake, and then you wait for a bit again, and then you eat it. So it has a bit of the same steps, but just a different outcome. So for these two recipes, you follow the same procedure, basically. And you can do this trick yourself. You could place these things next to each other and select which ones are the same. At least putting something in the pan, turning something around, wait. And you can then check what differs from each other. Either an egg or a pancake. Both of these ingredients are liquid, and this way you can come up with some similarities and practice this with your students. Practicing what is similar in classes like these and what differs from each other are super important whilst training these concepts of abstraction. This could be really fun in a drawing lesson. For example, if you would let your students draw their own family or school building, you shall see that there will be similarities in those drawings. Probably all these schools will have a door and a roof. However, there will also be differences, I'm sure. In the course material, there's a lesson in which Feline her class drew something in the style of Mondrian. In those drawings, I asked them to spot the differences and similarities and use that in their program. Of course, you can also do that for your code. I already showed you this when we placed these questions next to each other, practicing with distinguishing the similarities from the differences. Of course, here we can think of the levels of Piaget. Applying this new concept of abstraction right away will be very difficult. If I want to make a program like the quiz we did before, I would start with the generic block, as I understand that I want to do the same thing for all these questions. But you need experience and practice to realize such a thing. And you can practice this step by step by first writing a really long program and then let abstractions occur. In the next homework assignment, you can practice this very well, since one of the assignments covers creating these abstractions while working with tables. Lastly, there's a super important connection between abstraction and language I want to talk to you about. Since in language, there are also abstractions. Actually, when you think about it, everything in a language is abstraction. Since we can deal with the idea of a table very well, this is an example of a table, but every table is different. You can have a wooden table, a table made from metal, or a table like this one with one leg, like the one I'm standing at, but the majority of the tables has 4 legs. So this is a really nice exercise you could do with your students and ask, for example, kids, what is exactly a table? Probably they'll mention it has 4 legs, and then you can show them an image of a table with 1 leg. And then they would all go, oh yeah, that's actually also a table, but So it is something you can place something on, and you can play around with that a little bit. Come up with your own examples on how to explain abstraction to your students. To continue with my example, like the table, you could question again whether you can place something on it. Maybe there's this super old table somewhere in a museum on which you can't place anything on. But is it then still a table? No, yeah, they would maybe say, yeah, it's still a table then, but you can't place anything on it, I would say. But then they would maybe say, yeah, but it's still a table. But, okay, what if a table is super crooked, like this? So if it's like this, I can't put anything on it. Does it stop being a table then? You can't place anything on it anymore, that's for sure, because it will fall off. Yeah, is it then still a table? Maybe your students, you see them really struggling with then what a table is. So this was another example of a fun, unplugged exercise to do in class with a lot of concepts, and you can let kids discover and practice distinguishing things that are the same and what is different from each other. So again, what elements make a table? A chair is not a table, and a cat is also not a table. So there is a sort of state that makes a thing a table. But when and what is that exactly? That's super difficult. So this is a great exercise to do before you start with abstractions in Scratch, as you give the students some context. Good luck with doing this unplugged exercise in class.